this video, we're talking about how to find the degree measures of arcs or angles that are formed when we have two or more intersecting lines around a circle. And we can break this down into three scenarios, the first of which is where the point of intersection of the two lines is on the edge or on the perimeter of the circle, like in this first figure here. The second of which is where the point of intersection of the two lines or chords is inside the circle, like this figure here, or this situation where the point of intersection of the two lines is outside the circle. So we call that point of intersection the vertex, and that's just the vertex of the angle formed by the two lines. So think about it as, is the vertex on the circle, inside the circle, or outside the circle? And sometimes you'll learn about different situations depending on whether one or both of the lines is a tangent or secant line. Obviously, you could have both lines as a tangent line, both lines as a secant line, or one secant and one tangent line. But no matter which kinds of lines you're dealing with, the only thing that's going to matter practically is whether or not the vertex of those two lines is on the circle, inside the circle, or outside the circle. And in each of these cases, we're going to find a different relationship between the angle measure and the degree measure of the arc. So we'll come back to these in a second as we work through these examples, but let's take a look at this first example. We have the circle here, X. We've been given these three lines. This line here, YV, is tangent to the circle at the point Y, and to be tangent to the circle, remember, means that it just touches the circle at one point. So it only intersects the circle at the point Y. It's tangent to the circle at that point. And we have this secant line here, SY, and the secant line SV. So we've got three lines. We've also been told that the degree measure of the arc WT is 36 degrees, that the degree measure of the arc UY is 70 degrees, and that the degree measure of the arc TU is 148 degrees, and we have to find three unknown values. So the first thing we need to find is the measure of angle SYV. So let's go ahead and find SYV. SYV, so that's going to be this angle measure right here. Now to find that angle measure, we need to realize that this is the angle between a secant line and a tangent line whose vertex is on the circle. So let's go back over to our reminder section and look at this diagram here where the vertex is on the circle. When the vertex is on the circle, the degree measure of the inscribed arc, so the degree measure of this arc right here, arc BC, is going to be twice the degree measure of the angle, or you could say the degree measure is going to be 1/2 of the degree measure of the inscribed arc. So if we start at the vertex over here and we follow one side of the angle all the way to the other side of the circle, we get here to the point W. If we follow W back around to the vertex of this angle, we get all the way back here to Y. So the inscribed arc associated with this angle is the arc WUY or YUW. To find the degree measure of that arc, we would just have to add the degree measure of WT, the degree measure of TU, and the degree measure of UY to get the total degree measure of this inscribed arc. So what we would say then is 36, so 36 plus 148 plus 70 is going to give us 254 degrees for the degree measure of this inscribed arc. So what do we know based on this formula here? If the arc is 254 degrees, the angle measure is 1/2 of the degree measure of the arc, so we would just take 254 degrees, we would divide it by 2, and we would get 127 degrees. So then we could say that this angle measure here is 127 degrees. What about the measure of angle VSY? Well, if we go find VSY, we can see VSY, so that's going to be this angle measure right here. So this is the angle formed between two lines that have their vertex outside of the circle. So let's go look at our outside reminder over here. When the vertex is outside the circle, the angle of the vertex is going to be this B minus A divided by 2 degrees, where B is the larger inscribed arc and A is the smaller inscribed arc, and then we take the difference and divide by 2. So if I look at this angle here, YSV, or the angle S, I can see that I have my larger inscribed arc over here. I have my smaller inscribed arc over here. I know that this inscribed arc is 70 degrees, so I'm going to say 70. I want to subtract then the smaller inscribed arc, 36, and I want to divide that difference by 2. So 70 minus 36 is going to give me 34. 34 divided by 2 is going to give me 17. So I can say that this angle over here is 17 degrees. What about the measure of angle SVY? Well, if I go find SVY, SV, and then Y, that's going to be this angle right here. And what I can see is that the vertex of this angle is outside of the circle. So if I come back over here to the figure for the vertex outside of the circle, what I'm looking to do again is subtract the smaller inscribed arc from the larger inscribed arc and then divide the difference by 2. So if I go look for the larger inscribed arc, that's going to be this arc right here all the way down to the edge of the angle. The smaller inscribed arc is just going to be this arc right here. So in order to find the larger arc YT, what I'm going to have to do is find the arc YW and then add to that 36. Well, the arc YW is going to be 360 degrees minus the degree value of the other three arcs. So minus 148 minus 36 minus 70 degrees, and that's going to get me 106 degrees. So I can go ahead and say that this is 106 degrees, but I want to add back 36. So 106 plus 36 is going to give me 142 degrees as the measure of arc YT. What about the measure of arc YU? Well, I know that that's 70, so I just want to take 142, I want to subtract 70 degrees, and that's going to give me a result of 72 degrees. But then according to my formula over here, b minus a divided by 2, I need to divide this by 2 to get 36 degrees, and that'll be the measure of angle V over here. The other way I could have found that is by thinking about this as a triangle. I already know that angle Y is 127 degrees. I already know that angle S is 17 degrees, so I could have taken 180 minus 127 minus 17 to get 36 for the measure of angle V. What about this second example here? We have circle O with a tangent line and multiple secant lines. I've already been told that the degree measure of arc CD is 105 degrees. I also know that arc CD is congruent to arc AB, so since this one is 105 degrees, I can also say that this is 105 degrees and fill that in right away. I also know that the degree measure of arc BC is 47 degrees, and I know that line AF is tangent to the circle at the point A. I need to find several things. The first thing is the measure of arc AB. So if I come over here and I find the measure of arc AB, well, I already know that's 105 degrees because I was told that it was congruent to arc CD. So I can go ahead and say that this is 105 degrees. What about the measure of arc AD? Well, that's this arc right here, AD. I know that the sum of all of the degree measures of all of the arcs around the circle is going to be 360 degrees, and I already have 105, 105, and 47. So if I say 105 times 2, I get 210. 210 plus 47 is 257, which means that AD has to be 360 degrees minus 257 degrees, or 103 degrees, and I can go ahead and label this 103 degrees. Now I'm looking for the measure of angle AED. So if I find A and then E and then D, that's going to be this measure right here. I can see that the vertex of this angle is outside the circle. So looking here at my outside figure, I know that I need to take the larger inscribed arc and subtract the smaller inscribed arc. So here the larger inscribed arc is going to be this arc right here. The smaller inscribed arc is going to be this arc right here. So what I want to do is take the difference. So I'm going to get 103 minus 47, and then I want to divide that by 2. So 103 minus 47 is going to give me 56. 56 divided by 2 is going to give me 28. So I'm going to get 28 degrees as the measure of angle AED. What about the measure of angle CAF? So if I find CAF, I can see here that that's this angle measure right here, and I can see that the vertex of that angle is on the circle. So looking at my figure here for on the circle, I know that the angle measure is going to be 1/2 of the degree measure of the inscribed arc. So if I come over here and I look at the inscribed arc, I can start at the vertex and follow it along all the way to the other side of the angle CAF. So this inscribed arc here, the degree measure of that arc is going to be 103 degrees plus 105 degrees, which is going to be 208 degrees. If I take 208 degrees, and I divide it by 2, because the angle measure will be 1/2 of the degree measure of the arc, I'm going to get 104 degrees as the degree measure of the angle. For the last two, I've got the measure of angle CQD. So if I look at CQD, that's going to be this angle measure right here. That vertex is inside the circle, so if I go look over here at the figure for the vertex inside the circle, what I can see is that the degree measure of the angle is going to be equal to the degree measure of the inscribed arc plus the degree measure of the inscribed arc of the vertical angle associated with this angle divided by 2. So what I'm interested in then is this inscribed arc here, arc CD. I know that's 105 degrees. And then I also want the inscribed arc of the vertical angle. Well, here's the vertical angle, so I want the inscribed arc of that angle as well. That's this arc here, arc AB. That's also 105 degrees. So then what I need to do is just take 105 degrees plus 105 degrees and divide that by 2. Of course, that's just going to be 105 degrees, so the measure of angle Q here is 105 degrees. And finally, I've got the measure of angle BQC. If I go look at BQC, that's going to be this measure right here, this angle right here. The vertex of this angle is inside the circle, so if I come back again to my figure for vertex inside the circle, what I'm looking at is the degree measure of the inscribed arc of this angle. So the degree measure of this arc here, arc BC, is 47 degrees, so I'm going to go ahead and say 47 degrees. I also want to go find the vertical angle associated with this one, which is this angle here, and I want the degree measure of the arc associated with this angle, the inscribed arc, and that of course is this arc right here, arc AD, so that's going to be 103 degrees, so I want to add 103 degrees, and then I'm just going to divide that sum by 2. So 47 plus 103 is 150 degrees. 150 degrees divided by 2 is 75 degrees. So then I can say that this angle measure here is 75 degrees. And those are just a couple examples about how to find the degree measures of arcs and angles when you have a vertex formed by two lines and the vertex sits on the circle, inside the circle, or outside the circle.